So I'm doing question numbers 8 and 9 on Newton Extra Eutexis. And this question says, consider the 600 Newton weight held by two cables shown below, which I have already drawn. The left-hand cable had tension T, which is right here, and makes an angle of theta with the wall. The right-hand cable has a tension 620 newtons and makes an angle of 37 with the ceiling. What is the tension T in the left-hand cable slanted at the angle of delta with the with respect to the wall? So the first thing I'm going to do is split it into components. So that'd be, two triangles. So first triangle would be F1. Second triangle would be F2. And you should know that F net is equal to F1 plus F2. But F net in this situation is going to be 0. So then F1 is going to be equal to F2. So we're going to have two components, and it's going to be X and Y with the directions based purely on that. So we're going to get to that later, though, where we're going to have an F1 of X, an F2 of X, and an F1 of Y, and F2 of Y. Since we know that F1 is equal to F2, we're going to first solve for the X component. So I'm going to draw F1, which is like separate from this whole thing. And F1 is going to have a 37-degree angle here. It's going to have a 620 hypotenuse. So we're going to use SOHCAHTOA in this situation to solve for the X component, which is going to be right here. So first thing we're going to do is, since we know we're going to be needing to use adjacent over hypotenuse, we know that we're going to use the cosine. So it's going to be cosine of 37 is equal to X over 620. So multiply this by this, and you're going to get that X equals, which is F1 of X, is equal to 495.15. Okay, so now that we found F1 of X, that'll work, but the thing is, we're trying to find tension, which is the hypotenuse over here. So we really want F2 of X, but like I said before, F1 is equal to F2, whether it's X or Y. So F2 of X is also going to be equal to 495.15. Alright, the next thing we're going to do is solve for F1 of Y, using the same triangle that we used before. But this time we're going to find the Y component instead of the X component. So we're still going to have 620 here, and we're going to have the Y here. So this time we're using opposite and hypotenuse, which means we're going to use sine. So sine of 37 is equal to X over 620. So we're going to multiply this by this, and X is going to be equal to, forgot a very important step. One of the big deals with this component is that we need to subtract here, let me rewrite it. So we're going to have 620 sine of 37, and we're going to try to find Y. But a very important step is that we need to subtract this whole thing from 600, because we have that 600 newtons pulling down. So we got to remember that little detail, which I forgot. So Y now is going to be equal to 226.87. And these are all newtons. Now that we have both of our F2 components, I'm going to draw yet another triangle. And this one's going to represent finding T. So this is going to be your Y component, this is going to be your X component, and this is going to be T. So since we have the Y component right there and the X component right there, we're just trying to find hypotenuse. And to do that, it's very simple. All we have to do is a squared plus b squared equals c squared. So the first thing we have to do is a squared, which is 495.15. Plus b squared, which is 226.87 squared, and we're going to square root that so that we can find t. And then so we're going to end up finding that T is equal to 544.65 newtons. So now that we found T, we're going to jump right into number 9, because that's the answer to number 8. So that's your tension. And if you have any problems with that, look back earlier in the video and you should be able to find your answer. But we're going to go right into number 9 now. So we still have our components, so I'm going to rewrite our components. I'm going to keep that drawing there. Now the whole point of number 9 is to find theta. Theta is drawn on there. It's in the F2 component. And so we're going to be using the same exact components since we're dealing with F2 again. So component X is going to be equal to 495.15. And then component Y is going to be equal to 226.87. So we have our components. Now, with this image, we are trying to find this triangle, this theta here. So we're going to want to use our components to find that theta. So we're given opposite and adjacent. Opposite and adjacent. Sorry, this is adjacent, and this is opposite. Let me redraw that. Because we always relate it back to where the theta is. So we have opposite over adjacent. So, again, we're going to go back to SOHCAHTOA and see which one we want to use. And make sure you have your calculator in degree mode with all of this, because that might be your issue if you're having problems. You have to have it in degree mode. Radian mode will get you a different answer. So with this, it's going to end up being that you want to use tangent, so TOA. So tangent of theta is going to be equal to opposite, which is the x component, which is 495.15, over adjacent, which is the y component, which is 226.87. Now we can't just try to divide that out and find tangent theta. No, we need to get rid of the tangent on this side by multiplying it by tangent -1, which is going to reverse it, which means we also have to multiply this side by tan -1. So in reality, this is going to go away, and I'm going to go ahead and erase this, and we'll continue our work up here. So in reality, it's going to be tan -1 of 495.15 over 226.87 is equal to theta. And when you get that whole thing, solve everything out, you're going to find that theta is equal to 65.42. So that's your answer for question number 9. Alright, thank you for watching the video, and I hope it helped.